So if we follow the steps, and this is one case too where I would suggest making sure that you have all of the numbers already. Like I would go ahead and do each step all at once. I wouldn't do it once for the magnesium and then once for everything else. And it thinks I'm trying to change pages. I didn't mean to try to change pages. Let me tell it that I'm on page 6 and we'll see. Oh, it does not like that. Okay. So first step, turn them into grams. Now at this point, if you haven't paused the video, pause the video and go ahead and practice the other steps. It is so much better for you to try to do this on your own and have your brain actively engaged than just to watch me do it. Right. So let's say you don't have a periodic chart handy and you're not sure what to do. I do have a periodic chart listed under test 1 and test 2, test preparation. So you can go ahead and get that number from there. It's going to be, this is one that I don't use very often, so I had to look it up. 54 point, wait, let me do this in a different way so it's more clear. I'm going to grab these guys, I'm going to scooch them over. All right. So I'm going to go from grams of Mn to moles of Mn. And so he is 54.89394 grams in 1 mole. That's a magnesium or manganese. And again, I'm doing this all at once. While I'm in the flow of it. This one's 12.01. That's from the periodic chart, and that's in 1 mole. Those are all carbons. I'm going to scooch him over so he's got a little bit more space. And then grams of oxygen, moles of oxygen. This is 16.00 in 1 mole. So when you do the math and get your calculator handy, you're going to say 38.4 divided by 54.94. So I get this one is 0.699. It's kind of good to put a few extra decimal places in this. I could take it out to 4, even 4 places out. That'd be great. I'm going to do the next one, 16.8 divided by 12.01. This one gives me 1.3. Sorry, it's 1.399. So, just letting you know, like I've got that one rounds a lot. And then my last one, 44.77 divided by 16. So this one gives me 2.798. 2.798. So that's my moles of oxygen. This is moles of carbon. And then this is my moles of manganese. So if you can't remember what to do now, if we try to do the formula, you can always try to do the formula at any point, and then it'll tell you if you're good to go or not. So if we try to do that, you can see right away that we've got all kinds of craziness going on because I've got tons of decimals. So I'm going to divide by the smallest one. So I'm going to compare 0.69 to 1.3 to 2.7. Definitely the 0.69 is the smallest one. So when I do that math, I'm going to get one of these. Actually, I've already got the other number in my calculator. So the third number, so I'm going to do that one next. And this gives me 4.000, so that's, or 4.003, so that one's a really solid 4. And then 1.399 divided by 0.699, and I get 2.001. So that's definitely a solid 2. So the way I would write that guy is I would do Mn. Here, I probably should do it on the earlier page. I would call this Mn, because there's one of those. C, there's 2 of those, and O, there's 4 of those. And you can always double check looking at it and say, oh, is that right? Well, this is oxalate. That's -2. That must be +2. You know, you don't have to know that information. But you say, hey, that really is a real compound, so that'll work. And just double check it's the lowest ratio, and you're good to go. So if you can do this problem, you're in an awesome place. Now, I'm going to come back. I'm going to actually make this next one video 3. The idea behind this one is that you were going to work on different sections of this as a class, and I still think that it has definitely has some value in continuing that idea. But chapter 6, video 3, we'll come back and we'll do that one. Last little bit is that in the review, just to check yourself, to determine the percent composition per element, so percent composition was the first math we did, you only need the formula. And that's totally true. You only need something like C4H8 to figure out that you need 4 times the mass of carbon over the full mass times 100%. So yeah, that's all you need. It's just the element. And then the percent composition, it uses the mass of one element regardless of how many are in the formula. So this is true, but if they only ask for carbon, but just note that like it might be a multi-part problem where they ask you for all of them, so they might ask you for hydrogen or something else. So you might have to still figure out all the percentages. But if they just ask you for one element, you only need the mass of that one element. And I'm assuming that you know the molar mass of the formula. Okay, molecules with different molecular formulas, but the same empirical formula have the same properties. That's false. The properties can be very different. And if you know percent composition of each element in the formula, you can determine the molecular formula. So the percentage composition, that again, that's that first math thing. You can go back and look up the first math part. What that one gave was the empirical. Oh, I misspelled it, empirical. Oh, I totally misspelled it. Is that right? Empirical. Yep, so there you go. Hopefully this was helpful and you can go back and look at things. Definitely click on any videos, watch any links that I've got in here if you've got any questions, or leave me some discussion boards with questions.